Hey guys, in this video I'm going to walk through a proof of why the derivative of e to the x is actually e to the x. So we need to kind of go old school with this one and use the limit concept. If you remember way back when in the day, we had a definition of derivative that kind of looked like this. We had a couple different versions, but I'll do the h to 0 method. And we had f of x plus h minus f of x all over h. And that got us our derivative at x. And then sometimes we would plug in a instead of x here to use a specific value. But this was the definition of derivative, back in the first month of school. So we're going to actually apply that to this. So if we want f prime of x, we're going to do the limit as h goes to 0 of f of x plus h. So that's e to the x plus h minus f of x, which is e to the x, all over h. And now we got to do a little bit of manipulation. When you have something raised to the sum of two powers, you can actually split that up. So I'll show you, and then I'll explain it again. This is the same as e to the x times e to the h minus e to the x all over h. So when you multiply like bases, you add exponents, right? Well, this has the exponents already added together. So to break it down, we would split those up. It's really no different than if I had said, just something simple like x squared times x to the third is x to the 2 plus 3, right? Which is x to the fifth. But if I wanted to start with this and go backwards, this is what it would look like. So that takes care of that. Now, you might notice we have a common factor of e to the x here. So I'm going to go ahead and pull that out. E to the x times e to the h minus 1 all over h. Okay. And then, you really are looking for where the h is, because that's the only thing that we're taking the limit for. This e to the x term doesn't have an h. So I can actually pull that out. This is going to be e to the x times the limit as h goes to 0 of e to the h minus 1 over h. And this has its own explanation of what it is. You could put this in your calculator right now, plug in numbers really, really close to 0, and you will see that this entire limit goes to 1. There's a really elegant explanation of that, but it requires knowing something a little more advanced called L'Hopital's rule. It's a really simple explanation once you know the rule, but that's a little out of our scope of what we're going to cover. But that is the limit. You could just do this in the calculator if you want to check it, analytically, and you'll see that the limit is going to be 1, which leaves us with e to the x. F prime of x is e to the x when you start with e to the x. Okay, so just a little demonstration for you. Nothing you have to memorize necessarily, but just I thought it would be neat to kind of see where it comes from. All right, I hope that kind of made sense. And if you want to explore any of that a little further, like why this is the way it is, I'm happy to explain those too. All right, see ya.